Hi everyone, in today's video we're going to look at 15b, matching and allocation problems. We're going to start with bipartite graphs. Bipartite graph is a graph whose vertices can be divided into two disjoint and independent sets. Each edge in a bipartite graph joins one vertex from one group to a vertex in the other group. Okay, so that's an example of a bipartite graph. So this example shows two sets. There are two chess teams, knights and rookies. In knights, we have 5 players. Rookies, we have 3 players. So the edges shows the games that played by different players from different groups. The next concept we're going to look at is directed bipartite graphs. So directed bipartite graphs basically show us the indicate the direction. A directed bipartite graph is a digraph which can be obtained from a bipartite graph by replacing each undirected edge by a directed edge. This is an example shows teachers who can teach different instruments. So as you can see, for teachers we have 4 of them, and different instruments we have 5 of them. Let's put this example in a school context. Okay, if what we want to do is we want to allocate the teachers to teach different classes, but the problem is if you look at the directed edges, David is the only teacher who can teach trumpet and the flute. But for violin, we have 2 teachers. The problem is how do we allocate the teachers so we have enough teachers to teach different instruments? We can simply solve the problem if we can have 5 teachers and all of them can teach all the instruments we listed here. Okay, so that leads us to the next concept, which is complete weighted bipartite graphs. A complete weighted bipartite graph shows an equal number of vertices in each set. So this example shows 4 employees who can use 4 different machines. Okay, so rather than just randomly assign an employee to a machine, the factory could use information about how well each employee uses each machine, maybe consider how quickly each performs the task, so they can minimize the time they take to complete the task. Then the time taken would be the weights on the edges of the bipartite graph. Rather than writing all the weights on this graph here, we can actually summarize the time information in a table. Then we're going to use an algorithm called the Hungarian algorithm to help us to find the best way to assign each employee so we can minimize the time they take. Now I'm going to show you the steps of using the Hungarian algorithm. Let's have a look at this example here. The question below shows that there are 3 installation jobs pending and you have 3 workers to complete the jobs. Each worker has cost associated traveling to each of the 3 jobs. So this graph shows that we have 3 workers and they need to complete the 3 jobs. And on the edge, you can see the numbers, which is the cost. Okay, so you need to assign each worker to each job, and then you need to minimize the overall travel cost. So what we are going to do first is to summarize the information in this weighted network in a cost matrix. So this table is called cost matrix. So as you can see, for each row, we have worker 1, 2, 3, and each column represents the jobs. So for the number 40 here, it costs $40 for worker 1 to travel to complete job 2, $25 for worker 2 travel to complete job 1, $50 for worker 3 to job 1. So now let's have a look at the steps we need to take use the Hungarian algorithm. Step 1 is row reduction. What you need to do is find the minimum of each row, and then we subtract the minimum in each row. For row 1, the minimum is 15, row 2 25, row 2 25. So once you find the minimum, then you're going to subtract the minimum from each row. Okay, so now we have 25, 45, 0, 0, 5, 20, 35, 0. Okay, after we finish step 1, we're going to step 2, which is column reduction. Similarly to row reduction, for column reduction, we basically just need to find the minimum of each column. Then we subtract the minimum from each column. Okay, so for column 1, minimum is 0, column 2, 5, column 3, 0. Since column 1 and column 3 has a minimum of 0, which means the value will not change, the only values in the second column will reduce by 5. So now we have 40, 0, 0. Step 3, you need to test for an optimal assignment. So what you need to do is to draw minimum number of straight lines to cover all the zeros. For the line we draw here, they have to be either horizontal or vertical lines. Okay? Then you need to say if the number of lines equal to the number of rows or the number of columns, then we need to skip step 4 to step 5. Write down the new matrix. Then we can draw a horizontal line to cover 2 zeros. Draw another horizontal line to cover these 2 zeros. Then either a horizontal or vertical line to cover the last 0. So as you can see, we have 3 lines here, and this is a 3 by 3 matrix. So we can skip step 4 and go straight to step 5. You're probably curious, so what is step 4? We'll use another example to show you what you need to do for step 4. Step 5, we need to make the final assignment. What you need to do is to draw a directed bipartite graph with an edge for every 0 value in the table. For this bipartite graph, we have 2 sets. Set 1 shows worker 1, 2, 3. Set 2 is the 3 jobs. For the 0 value, we have worker 1 here. It linked worker 1 with job 3. So we need to draw an edge to connect 1, 2, 3. Then for worker 2, we have 2 zeros link worker 1 to job 1 and job 2. So job 1, job 2. Worker 3 is job 2 and job 3. Step 6, which is make the allocation and calculate the minimum cost. Okay. For worker 1, we're going to assign for job 3. Worker 2, job 1 or 2. Worker 3, job 2 or 3. Okay. Since worker 1 needs to do job 3, worker 3 has to do job 2. Therefore, worker 2 will need to complete job 1. Once we decide the job they're going to do, so worker 1, job 3 will cost $15. Worker 2, job 1 going to cost $25. Worker 3, job 2 will be $30. Minimum cost will be $15 plus $25 plus $30, which is $70. Alright, let's have a look at the second example. Okay, the question below shows the 4 employees 1, 2, 3, 4. The machines in a factory are represented by A, B, C, D. The number in the table are the times in minutes it takes each employee to finish the task on each machine. Okay, so we have the cost matrix have employee 1, 2, 3, and to use machine A, B, C, D. And the number here is the time they need to take to complete the task. Okay, remember step 1, we have row reduction. So we find the minimum of each row and then we subtract the minimum from that specific row. Row 1 minimum 30, row 2 30, row 3 30, row 4 20. Then we subtract each number from each row. That's the new matrix we have. Okay. Step 2, column reduction. We find the minimum of each column and then we subtract that minimum from that column. So column 1, 0 as minimum, column 2, 0, column 3, 10, column 4, 0. Except column 3, the rest of columns have a minimum of 0, so we only need to change the values in column 3. Subtract 10, we have 10, 0, 20, 20. Step 3, we test for an optimal assignment. That means we draw minimum number of lines to cover all the zeros. Then we check whether the number of lines equals the number of rows or columns. Okay, because this is a 4x4 matrix, so we need to check whether we have a minimum of 4 lines. So we can draw a horizontal line to cover these two zeros, another horizontal line to cover this zero, and a vertical line to cover these two zeros. Okay, as you can see, we only have 3 lines, so now we need to take step 4, which is shift 0. What you need to do for step 4 is to find the minimum of uncovered values. The uncovered value we have here is 10, 10, 30, 60, 20, and 50. So the minimum should be 10. Once we find the minimum, we need to subtract the minimum from all uncovered values, which means we need to take away 10 from 10, 10, 30, 60, 20, 50. The last thing we need to do for step 4 is to add the values situated at the intersections of two lines. So we need to find the intersection of the two lines, which is on 40 and 30. Okay. So that's the new numbers we get. It will be 0, 0, 20, 50, 10, 40. Then we add 10 to 40, 30 becomes 50 and 40. Once we complete step 4, we need to actually repeat step 3 again. We need to draw minimum of lines to cover all zeros, see whether we have 4 lines for this matrix here. We can draw a horizontal line to cover these 3 zeros. Draw the second horizontal line to cover these 2 zeros. Because for these 2 zeros, they are not in the same column or same rows, so we have to draw 2 lines to cover these 2 zeros. So now we have 4 lines for a 4x4 matrix. Okay, then we can keep going with step 5, make the final assignment, which is draw bipartite graphs. So for these bipartite graphs, we have one set for employees 1 to 4, and another set which is for machine A, B, C, D. Okay, then we're looking for the zeros, then join the employees with the machine. For employee 1, we have machine A, B, C. So we join A, B, C. Employee 2, we have machine B and D, C. Employee 3, we have machine D. Employee 4, machine A. Then last step, which is make the final allocation and then calculate the minimum cost. Okay. For this question here, as you can see, employee 3 must use D and employee 4 must be assigned to use machine A. So you can write down employee 4 and 3 first, and then we're left with employee 1 and 2. Since employee 4 must use machine A, then employee 2 left with B and C. This for employee 2, which is B and C as well. So now we need to consider whether we're going to assign employee 2 to use machine B, then employee 1 will be C. Or employee 2 to use machine C and employee 1 will be B. Okay, if we assign employee 2 to use machine B will be 30 and employee 1 will be C, which is 50. So the time will be 80 minutes. Okay, we need to check another combination, which is employee 2 to use machine C, which is 40, then employee 1 will be machine B, which is 40. So the time is still 80. Therefore, it doesn't matter whether employee use machine B or C. Now we can calculate the minimum time. Since we are going to assign employee 4 to use machine A, it will take 20 minutes. Employee 3, D, which is 30. Employee 2, if I assign to B, which is 30, employee 1 will be C, which is 50. So the minimum time will be 20 plus 30 plus 30 plus 50, which is 130 minutes.